7 on deck.
Okay, mate. 7 on deck.
On 17th of February 2013, at 0854 hours, vessel MV Unfortunate, which is 1994 built bulk carrier, with about 73,000 tons dead weight, arrived for loading operation and anchored at Richards Bay Port Anchorage, with her port anchor with 7 shackles on deck. It was an open anchorage, exposed to sea and weather conditions. Weather was quite rough, with Beaufort scale 5 to 6, with gusts of wind and heavy swell. Vessel was frequently rolling and pitching heavily.
Sir, we are dragging anchor and moving close to MV Bulker.
Vessel was drifting dangerously towards another vessel, which was anchored in the vicinity.
Anchor station, start picking up port anchor immediately.
Vessel used her main engines to increase the distance from other vessel, while anchor was still down, not away and dredging.
Sir, anchor is not coming up easily. There is lots of weight on the cable.
Okay, we have increased some distance from the MV Bulker. Keep hitting, chief mate. Keep hitting.
Sir, there is lots of weight on the cable. Sir, spark is coming out from the brake line.
You keep hitting, chief mate. You keep hitting.
The injury resulted in AB bleeding profusely from the neck area. He succumbed to his injuries and died on board. Richards Bay Anchorage, where vessel anchored, is an open anchorage and is exposed to the effects of weather, sea, and swell. The anchorage is not marked on chart as a designated anchorage. Vessel was in the outer fringes of a tropical revolving storm. Heavy weather in the area was primarily caused due to this TRS. Vessel had received the above forecast and was aware of the storm in the vicinity. Weight on the anchor cable was so much that the bow stopper pin got bent and ship staff had to renew the pin twice. Just before the windlass breakdown, vessel increased her main engine RPM up to full ahead and went up to about 5 knots with 7 shackles of anchor cable on deck. Vessel was actually dredging the anchor in order to increase distance from other vessel. This was one of the main reasons of so much weight and pressure on the windlass motor. During this period, the cable was fully stretched leading astern. Vessel had reduced ballast at the anchorage. Cargo hold number 4, fore peak and aft peak tanks, were partially deballasted and were slack. This added free surface effect to rolling. The most likely cause of the hydraulic motor explosion was overpressurization of the system due to excessive weight on the cable. Just prior to the incident, the anchor cable was reported leading astern and touching shipside. The anchor cable had stopped coming up and sparks were seen coming out from the motor. The contributory factors for excessive weight on the cable were a combination of dragging off anchor, heavy rolling and pitching, caused due to heavy swell, light condition, and free surface effect. The catastrophic failure of windlass hydraulic motor occurred due to overpressurization. These very important instructions to avoid excessive overload of the windlass system are always provided in the manual by the makers. To avoid unrateable loads affecting the windlass system, these safety rules have to be always followed. The windlass equipment is not designed to hold a vessel off fully exposed coast, in raw weather or in open sea. In such conditions, the extreme loads on the anchoring equipment will increase to such a degree that its components may be seriously damaged or lost. Sudden stop of the windlass during heave operation while keeping the control lever in heave position indicates that the maximum load of the windlass has been exceeded. The chain must be in a vertical position as far as possible to ensure the windlass is loaded by chain or anchor weight only. 2 persons are required to operate the windlass under severe weather conditions. 1 person operates the brake while the second handles the winch control lever. Before opening the brake, the winch control lever must be set to maximum load position in a heave direction that is high torque and low speed. Then brake can be opened and anchor chain can be heaved. Control lever must be kept in maximum load position even if the heaving time will increase. In case of sudden stop of the windlass during heave operation, the control lever must be kept in maximum load position. And windlass brake must be closed while keeping control lever in maximum load position. Once windlass brake is closed, the control lever can be released to zero or neutral position. Windlass is equipped with various safety components. Chain stopper is fitted for holding the vessel under defined conditions. Its holding capacity is 80% of the chain brake load. Windlass brake is fitted for temporarily holding the chain with less load. Its holding capacity is 45% of the chain brake load in case a chain stopper is installed. Emergency function of the hydraulic multiple disc brake is to prevent paying out of the chain in case the power supply fails. Let's understand how the catastrophic failure or explosion takes place in the windlass motor in extreme weather. If the tension of the chain exceeds the heaving tension of the hydraulic motor, the motor will turn in the opposite direction. This makes the motor act like a pump, which throws the hydraulic oil in opposite direction of the normal flow. Pressure builds up. In adverse weather conditions, when there is a long, heavy swell and the vessel is pounding badly, this pressure exceeds much more than the relief valve pressure setting that causes the explosion of the motor. Vessel should preferably use the chain stopper even while heaving up anchor in adverse weather conditions. This will stop the gypsy to turn in the opposite direction and act as a stopper device when the chain is pulled against working direction. We must follow these safety instructions. As per makers, the operator is responsible for the correct use of the equipment. Know the equipment before operating them for the safety of the vessel and crew on board.